Okay, so we're going to start our discussion on polynomials with first understanding what a polynomial is. A polynomial is anything with degree n, meaning it has some exponent on the x variable. The catch is you've got to have real numbers and your coefficient on that first term can't be 0. So a polynomial is anything that's got some coefficient or some exponent on x. Quadratic specifically is when your x is squared. And this a value cannot be 0, because if it was 0, then it would be linear, not exponential. Not quadratic. We'll do a little bit of review on factoring, the types of factoring that you need to be familiar with. The first is pulling out the greatest common factor. So if you look at this first polynomial, you should see that each one of these coefficients is divisible by 7. So that's a factor. We can also recognize that each one of these terms has x's in it. We've got 3 x's, 2 x's, and 2 x's. That means we can pull 2 x's out. And then we've got 2 y's, 3 y's, and 2 y's. So we can also factor out 2 y's. From there, we can write what's left over. So when we do 14 divided by 7, we get 2. X cubed divided by x squared, we took away 2 of those x's, so it's just x. We took away both y's. 28 divided by 7, we're left with 4. We took out both x's, and we are left with 1 y. And then 21 divided by 7, we're left with 3. We took out the x and the y. That is fully factored. The next method is to factor by grouping, meaning we put things together that have common factors. So if you look at this, these have m squareds, and these have n's. So that would be one way to group this. When we do that, we see that we can pull m squared out of both of these, and we're left with 4 minus n. And then when we look at the next one, we can pull 1n out, factor it out, and we're left with 4 minus n. The reason this works is because we've got something times 4 minus n and something else times 4 minus n. So this is almost like combining like terms, because what you're left with is those two things that you factored out times 4 minus n. The last one is when we're looking at trinomials. Trinomial means 3, a polynomial that's got 3 terms in it. The first thing that you always want to look for when you're factoring trinomials is there some common factor in this particular trinomial? And we should be able to recognize that each term is divisible by 3. So we can factor 3 out of it. We're left with 8x squared plus 14x plus 5. Now what we need to do is we need to factor this trinomial. And the way that we'll do that, first of all, don't forget the 3 that belongs on the outside. But you set up your parentheses and you think, what 2 numbers can I multiply together to get 8? Well, you can do 8 and 1 or 4 and 2. I tend to try 4 and 2 first. So we have 4x and 2x. And then you think, what numbers do I multiply together to get 5? I get 5 and 1. Some things that I pay attention to, because this is a plus sign, that means both of these will be the same, whether they're both positive or both negative. This is a plus sign, so it tells me that they're both positive. Now what I do is I see if this works. That's 8x squared plus 4x plus 10x. That needs to be 14, and it is, plus 5. So it looks like we're done, and that is factored. I'm not going to go into any more detail because you should have learned factoring last year in Algebra 2. This was just a review. Here we've got some special polynomials, and I do expect you to be able to factor these. If you take a look at the first one, this first term is a perfect square. That's 7 squared and x squared. This is a perfect square, 2 squared and y squared. So I'm going to look to see if this is a perfect square trinomial. So what I think about, if I make this 7x, and I make this one 2y, again, a plus here means they're the same, a plus here means they're both positive. I'm really checking to make sure the middle term works. 14xy and 14xy makes 28xy. The next one, perfect square with a subtraction, that's a difference of 2 squares. There's a formula for this. The formula is you take the square root of each, you make one of them positive and one of them negative. The next one is a sum of cubes. This has a pretty intense formula. The formula looks like this. A plus b times a squared minus ab plus b squared. So if we apply that to what we see here, we end up with t plus 10 times t squared minus 10t plus 100. Here you see a difference of cubes. Your formula is pretty similar. A minus b, a squared plus ab plus b squared. So if we apply that, we have r minus 2s, r squared plus 2rs plus 4s squared. I don't expect you to memorize these formulas, but if I give them to you, I expect you to be able to use these too. These I do expect you to memorize. So now on to what we're actually supposed to be learning about. We'll start with the components of a quadratic. Quadratics are always written as ax squared plus bx plus c. So if you take a look at the one listed, a is 1, b is 4, c is negative 4. What I'm showing you here, this graph in blue, that graph is x squared. In red, here, I've got 2x squared. And in pink, I've got 1/2 x squared. So as the a value gets larger, the graph starts to squish closer. As the a value gets smaller, the graph spreads out. I do hope that you can guess what's going on here. This green one is y equals negative 3x squared. So negative makes it look like a sad face. A positive a makes it look like a happy face. So what I'm showing in this next graph, again, the blue one is x squared. But now I'm changing this c term. This is the c term here. So in red, I've got x squared plus 3. And in green, I've got x squared minus 3. So if you take a look at this one, it's probably going to move down 4 units. Now we're going to start messing with that b term. B is right here. We always start with x squared. The red one is x squared plus 6x. The green one is x squared minus 4x. So if you notice, the c term in all of these is 0, and they all intersect at the origin, at 0. The b term will shift the graph not only right and left, but it'll also move it in a kind of parabolic arc. The most important thing for you to understand is that when you are adding, your graph moves left. When you are subtracting, your graph moves right. So here, you're actually seeing the graph of the equation you've been dealing with. There's x squared. We had x squared with a minus 4, so our y-intercept is negative 4. Also, we had plus 4x, which meant that our graph had to shift over to the left. Now, this is actually easier to graph by hand when you have an equation that is in vertex form. When it's in standard form, which is what you've been seeing, you can very easily identify your y-intercept. But in vertex form, you can see the vertex of the graph. So vertex of the graph is right there. That's the vertex of the graph. It's that point, so it's either at the bottom or it's at the top. The great thing about vertex form is it gives you the x and y coordinates of the vertex. So you automatically want to say the vertex on this graph is negative 3, positive 2. But look at it. Is it negative 3, positive 2? No, of course it is not. Again, one of those weird things. If you see a plus, you have to change this value to negative. If you see a minus, you have to change the value to positive. So this is not correct. The vertex, based on what I see, is 3, negative 2. So one of the things that we are going to be able to do is look at an equation and graph it without plotting a bunch of points. The first thing I recommend doing is looking at your y-intercept and plotting that point, which is negative 5. Now I'm going to go through a process called completing the square. Once I complete the square, my equation will be in vertex form, and when it's in vertex form, I can plot the location of my vertex. Completing the square actually requires that you sort of say, what if this happened? How can I make this equation fit into what I want it to fit to? So the first thing that we're going to do is we are going to take this minus 5 and we are going to move that to the other side of the equation so that it becomes y plus 5 is equal to x squared plus 2x. Now, in order to complete the square, that means I want this left-hand side, that's not the left, the right-hand side to be a perfect square trinomial. What you have to do is you have to take a look at this term. You have to cut it in half and then square that number. So half of 2 is 1 and 1 squared is 1. So what I get to do is add 1 to the right-hand side of the equation, but the rules of algebra always apply. So I also have to add 1 to the left. What happens when I simplify? Now my right-hand side is a perfect square. I don't even have to factor. There's my perfect square. So my vertex, remember we want the opposite of what we see. So the vertex is negative 1, negative 6, which is right here. And one of the other things that we can do is, because we know that there is symmetry, right? The vertex is the axis of symmetry. That means that there's a point exactly on the other side of that vertex as my intercept, my y-intercept. So this gives me some points that I can use to solve or to graph this. Eventually we'll start talking about finding zeros and using the zeros as well. But to simply sketch the graph, it'll look something like this. I'm going to complete the square again, but this time I've got a little wrench in my equation because this a value is 2. So what we're going to have to do is figure out a way to work with this equation so that a is not 2. However, before we do that, let's make sure that we plot the y-intercept at -6. And then we want to get that out of here and over on the left-hand side. Now, I can't have a perfect square if my a term is 2. That's just not going to work. So what we'll do is we'll factor that out. And remember, if you factor it out, you end up with 1/2 x. Then as we continue the process, this becomes not a very nice equation to work with. I need to cut this in half, and I get 1/4. And 1/4 squared is 1/16. What you do have to pay attention to when you start adding values to the left-hand side is that you didn't add 1/16. You added 1/16 times 2, which is 1/8. So you have to add 1/8 to the left. So then as we rewrite this, 6 could be thought of as 48/8, which means when we add more we get 49/8. And then our perfect square, x squared, nope, not x squared, x plus 1/4 quantity squared. So as we write out our vertex, we have -1/4, -49/8. That is going to be very difficult to see, but we'll do our very best. That vertex is really, really close to the point we've given. We're going to have another point here, and this is sort of what our graph will look like. Make sure that you go and click on the Desmos link and that you play around with the sliders, because I want you to be able to articulate what happens as a, b, and c values change, what happens when they're fractions, what happens when they're negative.